Calculate the expected value, variance and standard deviation for the probability distribution. So once again, these are the values from example 8. So the expectation of x is 2, and of course we can get that just from the symmetry of the distribution. The variance of x for this one was 0.5, and the standard deviation was 0.7071, correct to 4 decimal places. Let's tidy that up. I don't like it when it looks like that. So 4 decimal places. Now consider the probability distribution of y. So we want a relationship between x and y in the form y equals ax plus b. It doesn't take too long looking at this to see that that is 2x add 3. So 2 times 3 is 6, add 3 is 9, 2 times 2 is 4, add 3 is 7, and so on. We want to calculate the expected value, variance and standard deviation for y. So we might need to calculate that. So the expectation, well, we know that that's in the middle, so that's going to be 7. So let's think about the variance. So we need the expectation of x squared, so that's going to be 5 squared, so 25 times 0.25. And then 7 squared, that's 49 times 0.5. And then 9 squared, so that's 81 times 0.25. So that's 51, and then we need to take away 7 squared. So that gives us 2. And then the standard deviation is going to be the square root of that. So that's 1.414, and so on. So expectation of x and expectation of y. Well, it should be fairly clear that the expectation of y is twice the expectation of x plus 3. So note again the formula connecting the two variables and the formula connecting the expectations. If we look at var y, that's going to be 4 lots of var x. So once again the addition makes no difference but multiplication does, and note that that's 2 squared var x, and the reason I've done that is that this is a 2 squared, and then if you look at the standard deviation, it's actually twice the standard deviation of x. So overall what we notice is that the mean or expectation is affected both by multiplication and addition, but the dispersion of the data measured by variance or standard deviation is affected only by the multiplication. Now variance is actually a squared unit, so that's why we have it squared. Standard deviation is in the same unit as the original data, and therefore we just get a single 2 just here.